Hello again, YouTube. It has been a while since I have done a video on this particular robot. If you recall, this is my bipedal humanoid robot thing. You can see right now this is where the torso of the robot used to be. I've taken that off because I've been doing some more work on it, and I probably will be redoing most of those parts. As you can see, uh, the robot is pretty much the same kind of design, but I have replaced a lot of the aluminum parts with all these 3D printed parts. You could see, for example, these brackets, which used to be made out of aluminum. Uh, they used to be something like this. I replaced them with some ABS 3D printed parts. Uh, And the reason why I did that is, while these aluminum parts are stronger, uh, all the holes in the aluminum are not straight at all, not even slightly. Uh, Even though I tried to center mark them, you see, yeah, this is a center mark. It wasn't even close at all. And the holes are not straight, so I gave up on that idea, and I decided to use these ABS 3D printed brackets. What's probably going to happen is they're going to break, and I'll have to make them a lot thicker. Or what I could do, I guess, is make templates of these and drill into aluminum from those, which I might do uh, once I finish testing these and if these break. You can see this part is also 3D printed. A lot of the hinging parts are 3D printed. You see on the feet, I 3D printed these parts of the feet, so it has this joint motion. Uh, these are the same kind of linear actuators with which were on the robot before. The only difference is I used to have a piece of pipe here with a hole in it, and I replaced that with a 3D printed part, and that it's this part, and you could put a captive nut here, and then you have a 3/8 inch rod, which can yeah, it can go in and out. And even without the captive nut, you can see the plastic will screw in. See, I can't really just push it in there or pull it out. You have to screw it, which keeps everything tight, I guess. And also the mounting for the motor here. All of this is 3D printed as well to hold the motor in place. This part right here is still a piece of metal to join this is a cordless drill motor to join it to the rod. And also you can see all the electronics for the cordless drill stuff. That is still here as well. I need to desolder that and put on some new wires. You can see right here I've put linear actuators on every single joint, like this one back here, but I haven't put one here. So this is what it looks like without the motor. You can see the part would mount here and up here, so you could have a linear actuator right there. So that's what I've been doing to this robot. But one problem, which I still have not yet solved, is the hips. And these are the exact same hips which I had on the original robot. The whole idea was that instead of having these joints move outward, like that or that I would have a big weight here, and let's represent it by this drill, and it would move like that, and that would shift the weight of the robot to either side, something like that. Well, I tried that does work, but I have a problem, is that with the way these hip joints are mounted, if I lift up one, you can see this one just falls directly towards that one. It's not really held up by anything at all. So what I'm gonna have to do probably, this one. All right, so you can see there's supposed to be space in between them all the time, but there's not. So what I could do is I could just make these pieces thicker. That might solve the problem. Maybe it's in these little pieces. Maybe I need to make those thicker. Or also what I could do is have it so these joints can move outward by having a big gear here, and that would allow this joint to turn so it can always be in the right position. And these two legs, they can touch each other. They will be able to touch each other, but they will also be able to spread apart, and that will be at my own control, actively using the motors, and not at the control of just having whatever material is here not bend, because as you can see right now it does, especially with the weight of the motors all on it. Also, another thing that I'm trying to do right now is the feet. You can see these feet have a joint that goes like this. And what I want to be able to do is to control this motion. And there are several ways to do this. Probably the most direct way would just be to get in our one of these things and in our motor like this up here and just make another one of these linear actuators and put one right there. Good luck trying to fit it into there. Oh, of course I probably could if I redesigned this entire thing, but that's not what I designed it to do. Alright, so what's going on here is that there's a hole going across here, and there are two holes right here. You can see them. So what I'm going to do is maybe mount a piece of metal here or something that will have a bicycle brake cord, which are the cords you have on the bicycle brakes, so you can transfer a pulling motion through a cable, and that's what I'm going to do. So the motion will be caused by a motor, maybe on farther up on the robot. I could possibly put it on the knees or on the hips or something. That's where the motor will be, but the motion will be caused right here, allowing this to move up and down like this. Now that I think about it, I could probably copy the same motion for the hips. I could just basically make the hips like the toes, and then instead of having like the feet, I could connect them two together, and that could possibly give the same motion. And maybe up in the torso, I could have the linear actuators, maybe like stacked like here, maybe 4 of them, so that they could pull the joints and cause the robot to move out the hips and the toes all at the same time. Actually, I could probably combine 2 of these motions into just one motor. I could have probably, if I just want to make a walk, I could probably just have one motor actuate all 4 of these joints in both the hips and the toes, and that would be a pretty easy thing to do. I won't even really have to make any new 3D models, but I'm going to have to buy more 3D filament. Probably going to have to do that anyway, though. So that's where we are right now, just for the structure of the robot. After that, we could get to the controls of how the robot is actually going to be controlled. I have some more ideas on how that would work. Maybe potentiometers in either of the joints. I really don't know. So I'll make another video when I get an idea for that, or when I have made significant progress on the robot. So that's it for now. Goodbye.